Thermodynamics. Definitions, a bunch of definitions for this first page. Definition of bond dissociation, enthalpy. Enthalpy change when all the bonds of the same type in 1 mole of gaseous molecules are broken. Definition of enthalpy change of atomization of an element. Enthalpy change 1 mole of gaseous atoms is formed from an element in standard states. Definition of enthalpy change of atomization of a compound. Enthalpy change 1 mole of a compound in standard states converted to gaseous atoms. Definition of enthalpy change of atomization of a compound. Enthalpy change 1 mole of compound in standard states converted to gaseous atoms. A definition of first electron affinity. Enthalpy change 1 mole of gaseous 1 minus ions is formed from 1 mole of gaseous atoms. Definition of second electron affinity. Enthalpy change 1 mole of gaseous 2 minus ions is formed from 1 mole of gaseous 1 minus ions. Definition of enthalpy change of hydration. Enthalpy change 1 mole of aqueous ions is formed from 1 mole of gaseous ions. Enthalpy change of solution. Enthalpy change 1 mole of solute is dissolved in enough solvent so that no further enthalpy change occurs on further dilution. Enthalpy change of solution. Enthalpy change 1 mole of solute is dissolved in enough solvent so that no further enthalpy change occurs on further dilution. Lattice enthalpy, what is it? It's a measure of ionic bond strength. There are two types of lattice entalpies, which is measures of ionic bond strength. Lattice enthalpy formation. Enthalpy change 1 mole of a solid ionic compound is formed from its gaseous ions under standard conditions. Lattice enthalpy of dissociation. Enthalpy change 1 mole of a solid ionic compound is completely dissociated into its gaseous ions under standard conditions. So lattice enthalpy of formation. 1 mole of solid ionic compounds formed from its gaseous ions. Lattice enthalpy of dissociation. 1 mole of solid ionic compound completely dissociated into its gaseous ions. And remember, with both of them, under standard conditions, under standard conditions. State 2 key assumptions of the purely ionic model of a lattice. It assumes all ions are spherical, and it also assumes they have the charges evenly distributed around them. Assumes all ions are spherical, have the charge evenly distributed around them. Describe what happens to occur partial covalent bonding. I've worded this really badly, but basically positive and negative ions aren't exactly spherical. I'm not going to say aren't spherical, they aren't exactly spherical. Positive and negative ions aren't exactly spherical. So what happens? Positive ions polarize neighboring negative ions to different extents. More polarization, more covalent the bonding. Positive ions and negative ions aren't exactly spherical. Positive ions polarize negative ions, polarize neighboring negative ions to different extents. More polarization, more covalent the bonding. Say 2 key things when solid ionic lattice dissolves in water. The bonds between ions break to give free ions. This is endothermic, positive delta H. Bonds between ions and water are made, negative delta H, exothermic. And then enthalpy of solution is the overall effect on enthalpy of these two things. Enthalpy of solution, overall effect on enthalpy of these two things. Why do soluble substances have exothermic enthalpies of solution? Because the idea that substances generally, why do soluble substances generally have exothermic enthalpies of solution generally? Well, substances usually generally only dissolve if energy is released. If energy released is the same or greater than energy taken in. More arrangement equals more stability, or more stable, more disordered, more stable. Definition of entropy. S, a measure of the number of ways particles can be arranged and the number of ways energy can be shared out between the particles. Definition of standard entropy of a substance. S, and it's like a circle with a line between it. Entropy of 1 mole of that substance under standard conditions. Entropy of 1 mole of that substance under standard conditions. Standard conditions 298 Kelvin and 100 kilopascals of pressure. And then just to finish it off, if delta H is positive and delta S is positive, so if it's an endothermic direction and entropy change is positive, the reaction won't be feasible at some temperatures but will be feasible at high enough temperatures. If delta H is negative, it's exothermic and negative entropy change, then the reaction will be feasible at lower temperatures but won't be feasible at high temperatures. If delta H is positive and delta S is positive, reaction won't be feasible at some temperatures but will be at high enough temperatures. Reaction won't be feasible at some temperatures but will be at high enough temperatures. That's with positive delta H and positive delta S. If delta H and delta S are both negative, then the reaction will be feasible at lower temperatures but won't be feasible at higher temperatures.